All right, if you think Wi-Fi 7 is just, another small speed bump, you've got to think again. We are talking about a fundamental shift in how our devices connect to the internet. And it's all thanks to this one truly groundbreaking feature, multi-link operation, or MLO for short. And believe me, this isn't just about making your downloads a little bit faster. It's about making wireless as reliable and as solid as a physical cable.
Okay, so here's how we're going to break this down. First, we're going to talk about the problem MLO was built to solve, that classic Wi-Fi traffic jam. Then we'll get into the core concept, this idea of a multi-link device. After that, we'll pop the hood and look at the new architecture. Then we'll explore the different strategies it uses. And finally, we'll put it all together and see why this is truly a game changer for all of us.
So before we can really appreciate just how brilliant the solution is, we have to talk about the problem. And honestly, it's a problem every single one of us has experienced, probably even today. Let's call it the Wi-Fi traffic jam. You know the feeling, right? You're on a super important video call, or you're deep in a gaming session, and boom, everything just freezes. You glance over at the Wi-Fi icon, full bars. So what gives? Well, you're stuck in that wireless traffic jam. And until now, Wi-Fi has had let's just say a very clumsy way of dealing with it.
And this right here really gets to the heart of the issue. See, traditionally, your device, your phone, your laptop, whatever, it could only connect to your router on one single band at a time. So maybe it picks the 5 GHz band, but that means the 2.4 GHz band and that shiny new 6 GHz band are like these perfectly good empty highway lanes that your device just couldn't use. So if its one chosen lane got all clogged up with interference, maybe from your neighbor's Wi-Fi or even your microwave oven, well, tough luck, you were stuck.
The only way out of that traffic jam, your device had to completely disconnect from that band and then reconnect to a different one. It's a process called reassociation, and it is slow. The best analogy is exiting a jammed highway, crawling through side streets, just to merge onto another highway. And for anything real-time like gaming or a video call, that little detour creates those awful lag spikes and drop packets. It's what makes Wi-Fi sometimes feel so unreliable.
So how does Wi-Fi 7 fix this incredibly frustrating one-lane-at-a-time problem? Well, it doesn't just try to patch it. It completely rethinks the whole connection by introducing a brand new kind of device. Okay, let's really break this down, because this right here is the heart of the whole revolution. It's called the MLD, or multi-link device, and it's no longer just a device in the old sense. Think of it as a logical entity, a brain, that can manage multiple connections at the exact same time. So to your computer, to your phone, to your apps, it just looks like one single, super solid, ultra-reliable connection. But under the hood, it's actually a whole symphony of different links all working together perfectly.
And this visual just makes the change so clear. I mean, look at this. Before MLO, one association request, one radio. That was it, end of story. But after MLO, a single multi-link setup establishes these persistent parallel links across all the available bands. So now your device is connected to the 2.4, the 5, and the 6 GHz bands all at the same time. There's no more switching, no more dropping off one highway to get on another. It's just a seamless, dynamic use of whatever the best path is, moment to moment.
Okay, before we go any deeper, let's just quickly lock in a few key terms so we're all on the same page. It's pretty simple. A link is just the connection on one specific band. STA, or station, is the technical term for any Wi-Fi device, like your phone or laptop. And APMLD is just our new way of saying an access point or a router. And a non-APMLD is the client device, like your phone. Got it? Good.
All right, so how does this magic actually work? We know what an MLD is, but now let's go under the hood and see how it's possible for one device to juggle all these connections so smoothly. The answer, it turns out, is in a really clever redesign of something called the MAC layer, the Media Access Control Layer. So here's the secret sauce. They split the MAC layer in two. At the very top, you've got the upper MAC, or UMAC. I want you to think of this as the MLD's brain. It's the central manager, the shot caller that sees the whole picture. Then, underneath it, each physical radio, the one for 2.4 GHz, the one for 5, the one for 6, each gets its own lower MAC, or LMAC. The LMACs are the workers, the hands, each one focused only on its own specific link. And this division of labor is what makes MLO so incredibly powerful. The upper MAC, the brain, is link agnostic, meaning it doesn't care about the specifics of any one link. It handles the big picture stuff for the entire device. Things like setting up the connection, managing the security keys, and most importantly, deciding which link is the best one to use for the next chunk of data. Meanwhile, the lower MACs are link-specific. They are totally in the weeds, handling the nitty-gritty for their own frequency, like listening for a clear channel, sending back acknowledgments, and even managing power saving just for that one link.
So how do these two MLEs actually set up this really sophisticated connection? Well, it's like a little four-step dance. First, they find each other and announce, hey, I can do MLE, that's discovery. Second, your device, the client, sends a single request that basically says, awesome, I'd like to connect on these specific links. Third, the router responds saying, cool, those links are good to go, and here's a single ID for our entire MLD connection. And finally, there's a single security handshake that secures the entire MLD to MLD connection at once, not just link by link. It's super efficient and incredibly robust.
Okay, so now you've got this amazing multi-lane wireless superhighway connecting your devices. The big question is, how do you actually use it? What do you do with all these lanes? Well, MLO comes with a whole playbook with different modes and strategies that are tailored for exactly what you're trying to do.
And this chart gives us a great overview. See, there isn't just one MLO mode. It scales depending on the hardware in the device. So weighed on at the basic level, you have MLSR, which lets a really simple, low-power IoT device just switch between links. Then you have eMLSR, which is really the sweet spot for most of our phones and laptops. It lets a single radio listen on multiple links and then just pick the best one. And then, at the very high end, you've got STR, which lets something like a high-end gaming PC with multiple radios actually transmit and receive on different bands at the exact same time.
Now this is the holy grail of wireless performance. It's called simultaneous transmit and receive, or STR. Now, a device does need at least two separate, well-isolated radios to pull this off, but the payoff is just huge. It means your device could be downloading a huge file on the 6 GHz link, while it is simultaneously uploading a video on the 5 GHz link. This is true, honest-to-goodness parallel communication, something Wi-Fi has simply never, ever been able to do before, and the performance it unlocks is just incredible.
But here's the thing. You don't need a super high-end, multi-radio device to get huge benefits from MLL. And this is where eMLSR comes in, and it is absolutely brilliant. A normal, cost-effective single radio device, like the one in your phone, can listen in on 2 links at the same time in a really low-power mode. But the second it needs to send or receive data, its UMAC brain instantly picks the clearest, fastest link and switches to full power on just that one. So you get all the reliability and the low latency benefits of MLO, but without the extra cost and battery drain of having multiple radios.
So, once you've got these links and these modes, it really comes down to 2 main strategies for how to use them. It's basically a choice between speed and reliability. If you want raw speed, you use aggregation. This is where you split a single data flow like a huge 8K video stream across multiple links, combining all their bandwidth. But if reliability is what you care about most, you use duplication. Here, you send the exact same data packet over 2 different links at the same time. If one gets blocked by interference, no problem, the other one gets through. The receiver just takes the first one that arrives. This is perfect for things where you can't afford a single dropped packet like VR or competitive gaming.
Okay, so we've gone pretty deep into the architecture and the different strategies. Let's pull back now and connect all this incredible tech back to the real world. What does this actually mean for you and the things you do every day?
Less than 1 millisecond. Let that sink in. That's the goal, and in a lot of cases, it's the reality with this tech. By intelligently picking the best link at any given instant, or by duplicating that critical data, Wi-Fi 7 with MLO can get real-world latency down below a single millisecond. And that's not just an improvement, that's a whole new category of performance. It unlocks applications that were just flat-out impossible on wireless before now.
So this is what your new Wi-Fi experience looks like. It's not just faster, it's smarter and way more resilient. We're talking about insane throughput by combining bands together. We're talking ultra-low latency for perfectly responsive gaming. And we're talking about a level of reliability that genuinely feels like you're plugged in with an Ethernet cable. If your 5 GHz band suddenly gets congested, your traffic is already flowing over the 6 GHz band before you can even blink. You will literally never even notice it happened.
And look, this isn't just hype or stuff on a spec sheet. The experts are seeing this in the real world. This quote from the Wireless Broadband Alliance basically says it all. MLO isn't just about speed, it's a foundational reliability feature. It fundamentally changes the conversation about Wi-Fi from just how fast is it to how reliable is it. It's about making wireless a technology that you can finally trust for your most critical, most time-sensitive applications.
And really, that's the question MLO leaves us with. It's an enabling technology. It's what opens the door to a future of truly wireless, high-fidelity VR and AR, to cloud gaming that feels like the console's right there in the room with you,
to industrial and medical uses that demand absolute perfection. For the very first time, we're combining the incredible flexibility of wireless with the rock-solid dependability of a wire. And the possibilities? Well, they're just starting to unfold.